Hello students, welcome. Dr. Mayaduna here. I am showing you this like a pre-lab or the laboratory lecture for the lab. The lab for this week is doubled replacement reaction. This reaction is between potassium iodide and lead nitrate. I'll use this explanatory video to teach you the lab as well as give you some knowledge on how to write the chemical formulas, how to balance the reaction, and at the same time, how to look at some stoichiometric aspects of this reaction. So let's look at this reaction. This is a very interesting reaction in chemistry, showing a good color change reaction. The reaction is between lead nitrate and potassium iodide. So at the very first, when you look at it, it says the reaction is lead 3 nitrate lead 2 nitrate. That makes you think why they put 2 there, why they just write lead nitrate. No, you can't do it because lead is the compound that shows more than one charge. So that's this particular compound, lead 2 nitrate, that shows you lead has the valency or the charge of 2 plus. Lead always metal. Nitrate is the anion, nitrate is NO3. Nitrate is the NO3 minus. Or this is nitrate is the mono the multi so it has like two compounds, so it is polyatomic anion. So the lead nitrate and potassium iodide. So the very first question they are asking is write the balance react equation for the reaction between lead nitrate and potassium iodide. They make you the um, they make the reaction easy, the question easier by giving you, okay, this is how you write lead nitrate. Here Pb, lead is Pb, NO3 is nitrate, is a polyatomic anion, and then lead, the two belongs to both N and O3. Now this is nitrate, so you put the two outside. And then the potassium iodide, Ki. So let's first look at how do you write the balanced chemical reaction. Ki, PbNO3. Okay, so this is my screen. I'm gonna write the answer here. Let me see if I can write it here. Okay, so my reaction is between Ki. I write my potassium iodide plus PbNO3 twice, and then I put my I write my products. I'll use a different color so it makes it easier for you to see. And then you put your arrow. It should be in a one line. So then my trick is, so this potassium is the metal, iodide is the anion, K plus iodide anion. Here Pb2 plus NO3 minus. So always potassium goes with NO3, so you get the products KNO3 plus PbI2. Lead nitrate and potassium nitrate and lead iodide. This is the reaction. Once you write the reaction, you can stop. You have to balance the reaction. How do you balance? You see two nitrates here, but you have only one nitrate. So you put the two. Let me use another color for balancing two. So you put the 2 in front of it. And then you have 2 iodide, so you put 2 here. So you see 2 potassiums, 2 iodide in the product side, 1 lead, 2 nitrates, 2 nitrates. So this reaction is now balanced. So that's how you write the balance equation. Once you write the balance equation, oh, I erase it. I shouldn't have erased it. Let me write it really quick again. Here, potassium iodide plus PbNO3 twice, PbI2, doesn't matter which one you write first, KNO3, I'm balancing my reaction, 1 Pb, so then I put 2 here, 2I and then I think it's balanced now. So this reaction, the second question they're asking is um, pick the uh, pick for every pick for every statement for potassium iodide and let two nitrate that describe this reaction. So I can see for every 2 moles of potassium iodide, the reaction uses 1 mole of lead nitrate because the reaction is potassium iodide and lead nitrate is 1 to 2 mole ratio. So always 2 moles of potassium iodide goes with 1 mole of lead nitrate. Similarly, they ask to pick the statement potassium iodide, always 1 mole of potassium iodide goes with 2 moles of lead iodide. So that's the, so you need to look at the reaction and then you can lead nitrate and lead iodide. It's lead nitrate and lead iodide. You can see, okay, it's, what is the mole ratio? It's 1 to 1, 1 to 2. It's like that. What is the, so this next question they ask, what is the molar mass of potassium iodide? Let me teach you, potassium iodide is easier, I will say. I will teach you how to find the molar mass of lead nitrate. So for the lead nitrate, uh, again I need to connect with the dosary. You can see. Yeah, so the lead nitrate, I have PbNO3. I need to find what is the molar mass of lead, what is the molar mass of nitrogen, like that. So I need this data. Let me go back. Yeah. So I go here, then I found molar mass of lead, mass of Pb. You can use the periodic table, it's easy. I don't have it in front of me. Pb. So molar mass of Pb is 2 or 7.2 and nitrogen 14. I just use the let me see, Pb is 2, it's okay. So nitrogen, okay. Nitrogen 14, and then similarly the molar mass of oxygen is 16. So I have, so the important thing is I need this 7. Okay, so here I have Pb. First I need to find the NO3, so I have 1 nitrogen which is 14 and oxygen is 16 into 3, right? 16 into 3, so it's 48. 48 plus 14, 2, 62. And then 62 into 2, it's going to be 2, 4, 124. So 124, I add with 207, I get 431. Let me see whether I have that answer. Oh, lead nitrate. I think I did PPNO3. They asked lead to nitrate. What the mistake I did. There's some mistake. Sorry, it's 331. Sorry, it's the 331. Sorry, I just add something different. So it's like that, so that you know how to find the molar mass of anything. So this is a very complicated one I did. So you can do the rest. So then I'm going to do the little part of the make the prediction. So let me run this one really fast. The trial. So for trial, it's I think I have to start from the beginning. Let me go with the trial 1. I'll start from the beginning. So you have the lead, it's 67.7, you see. Okay, wait. I want to see here. Okay, so now you know the empty beaker is 67.71. That's you need to one record because they add to the empty beaker. So you need to know the weight of the empty beaker 67.71 and then they add in 67.71 and then 70. Here is another trick. So 67.71. Before water, you need to add the mass of lead nitrate. Before water. I think this is the one. Okay, 71.16. So they ask the mass of the lead nitrate. What you do, 71.16 is the mass with the lead nitrate and the beaker, and then you subtract the mass of the beaker, which is 67.71. So you get the mass of lead nitrate. I would say I didn't subtract, but I think it should be around like 3.45, something like that. Then they ask you to they ask that, so you get that, and then make sure the video set to trial one how much potassium iodide to start with. So let's look at the potassium iodide moles, right? They ask you to ask the moles. Let's see how to find the moles. So they finished the lead nitrate part here. Okay, now we are going to the potassium iodide. I can see the potassium. Okay, let me see. I can see the potassium iodide. Eye level measurement is given. So this one, the same cylinder, this is given in the eye level measurement, which is you have uh, 12 milliliters of potassium iodide. You see this, they make expand this small piece here. 12 milliliters of potassium iodide they are using, and then the concentration is 1 molar. What is the meaning of the 1 molar concentration? 1 molar means if you take 1000 milliliters, you have 1 mole of potassium iodide. But now, right now, you don't have 1000 milliliters. How much you have? You have only 12 milliliters. So how many moles in this 12 milliliters? Let's see how we can do that. Oh, let me connect the dosimetric stuff. Okay, I'm here. Okay, I'm here. So I need strokes. Okay, now I'm in the this part. I think it's desktop. Okay, so I have let me get a good piece of paper. Yeah, so now I have 1 molar potassium iodide, which means if I take 1000 milliliters, I get 1 mole. Now I don't take 1000 milliliters, I take only 12 milliliters. How many moles I'm getting? So 1 mole. So it's into using 12 into 1000 milliliters cancel, and I'm getting my answer 0.012, right? 0.012 when you divide it. So that's my answer I'm getting. I'm going back to my lecture, and then that's how you find the answer of the potassium iodide. And then they ask another question, I think. For first trial, how many moles of lead nitrate are present at the beginning? So we know, just imagine we use 3.45 this mass. Always find the moles. You can find the moles by mass divided by molar mass. Mass divided by molar mass will give you the number of moles. Sorry. So we know the mass is 3.45 grams. You divide by the molar mass, which is 331 moles per gram. And then this goes up, and then you can find the number of moles of lead nitrate. And then, okay, and then the first trial, how many moles of potassium iodide present at the beginning? We did that. the potassium iodide present at the beginning, we did that. And then 0.012 mole. And then what will be the limiting reactant for your first trial? So you need to find the number of moles of each reactant, and then you see this reaction is happening in 2 to 1. So if I look at the balanced chemical reaction, 2 potassium iodide plus PbNO3 twice, PbNO3, and then when you so then you get the product KNO3 plus PbI2, and then when you balance it you get 2 here. So this is mole ratio is 2 to 1. So now you need to find the number of moles of, we already know number of moles of potassium iodide is 0.012. Lead nitrate, just assume the number of moles is 3.45 grams divided by 331. Let me do it really quick. Calculator. So I'm getting number of moles as 0.010. So you need, in order to go to the reaction to complete, if you have one, you should have twice of this one. Right now, you have like almost same, right? So you should have twice of this one to the reaction to complete. This is even extra. So I feel like for the first one, the limiting, in order to complete this reaction, you should have like this one 0.01, this one you should have 0.02. Because of that, this is the limiting, because it's 1 to 2. So this should have twice of the number of moles we have present in the potassium nitrate. Because of that, in the trial 1, the limiting reactant is potassium iodide. Okay, so we're gonna go in the trial like that. You have to find the number of moles of potassium nitrate, lead nitrate and the potassium iodide, and see. But I showed you, okay, this is how you find the potassium iodide moles. This is how you find the lead nitrate moles, and then you see the comparison and see which one is the limiting reactant. Just keep in mind, limiting reactant. Wait a minute. Limiting reactant will be different in each trial. Okay, go down. And then, so this is the end of part 1. And then the third question, number 13, it asks, in the second trial, how many grams of lead iodide should be produced? So, lead iodide should be produced. You can do it this way. So, again, you need to look at the reaction. Potassium iodide, lead nitrate, you get PbI2 plus KNO3 twice, you put okay, 2. So, you know, if you look at the very first one, you know this is 0.012. We found this was 0.01. So, I'm using first trial because I did only first trial. How to find the lead iodide moles. Always, if you see these two reactions is 1 to 1. If you have 1 mole of lead nitrate, you have 1 mole of lead iodide. 1 to 1. Always in the reaction, the stoichiometry is important. What is stoichiometry? The number when you balance a reaction. Number present in front of each reactant. So lead nitrate is 1, so the lead iodide also 1. In that way, the number of moles in the lead nitrate at the given time of a reaction will be equal to the number of moles of the lead iodide. So here is we have 0.1 moles, same as we produce 0.01 mole of lead iodide. They ask you the mass. How to find the mass? You know the number of moles. You multiply by molar mass. You can easily find the molar mass of lead iodide we already found. So then give the number of moles multiplied by molar mass will give you the lead iodide. So that's how you do this reaction part 1, and then part 2, it's the video shown same trials part 2. We'll use the compare the prediction as actual amount to the products. Um, in your first trial, how many grams of the lead iodide produced? This is compared to your prediction. You have to you do the prediction and then you compare it and then you write the answer. But always the way to find the lead iodide is compare 1 to 1 mole ratio. Because it's always number of moles present in the lead nitrate will be equal to the number of moles in the lead iodide. In other words, half number of potassium iodide will be equal to the number of moles of lead iodide present. So that's how you complete this experiment. I showed you the most of the calculations involved in the trial 1. You have 4 trials in the experiment, and I hope this video is helpful for you to understand and to do this lab effectively. And if you have any other questions anytime, please feel free to email me, and I'm here to help. Thank you again. Bye.